Okay, so this mini lecture is just going to go through some standard forces that interact with objects that we want to be attentive to and appreciate that they exist in certain situations. It might not always be told to us that they exist, so we have to be able to infer when certain forces are interacting with an object. So let's talk a little bit about some of those forces. The first force that we're going to talk about is the force of gravity. Now, the force of gravity actually goes by another name. The force of gravity goes by the name of your weight. So the force of gravity is actually the same thing as your weight. So, how does the force of gravity work, and what are the objects that are interacting? Remember, for every force, there's an interaction of two objects. The force of gravity we categorize as F sub g is the interaction between the object and the earth. So, let's imagine that we have a book sitting on a table. Well, the earth is interacting with this book sitting on a table because the table is on the earth. And we know that mass of the earth results in a gravitational force. We call it the force of gravity. So just because these two objects have a mass, they're interacting with each other through this gravitational force. We call this force of gravity the one that's between the object, in this case the book, in our example, and the earth. Now, the force of gravity is one we really have to pay attention to. It's pretty much in every analysis that we're going to do. We're going to look at the forces acting on an object, and the force of gravity is going to exist. So when you're analyzing forces and then how forces affect an object's motion, you're pretty guaranteed to put the force of gravity in your analysis. So let's take a minute just to pull back and talk about that force of gravity. Well, like all forces, and Newton's second law tells us that masses and accelerations are part of those forces. For the force of gravity, it is defined as the mass of the object, or it's determined. It's the mass of the object times its acceleration, and the acceleration we're talking about is the acceleration due to gravity. Now, this I'm going to identify as the magnitude right now. The magnitude of the force of gravity is equal to the mass of the object times the acceleration due to gravity. Now, we want to keep in mind that mass is sort of the stuff of the object. It's a property of the object that is just based on the molecular makeup of that object. The acceleration due to gravity, well, that's the one we talked about in kinematics, negative 9.8 meters per second squared. When we're dealing with just the magnitude of the force of gravity, just the number, we will often see it written as mg, where g is equal to the magnitude of the acceleration due to gravity. Oops. So that magnitude, that absolute value symbols on the side of this is magnitude. So g is 9.8 meters per second squared. So this is often how we'll represent the force of gravity. We want to keep in mind that the force of gravity is always acting in the same direction as the acceleration of gravity, in the downward direction. So as we start to identify these forces, it'll be helpful for us to identify the direction that that force is acting in. So one type of force that we're going to look at in our problems as we develop our analysis tools is the force of gravity. The force of gravity exists even though we don't say it does. If an object has mass, we aren't going to say, and there's the force of gravity in the problem. We have to remember that any object with mass is interacting with the Earth's mass in this form. All right. Another force that we're going to be thinking about is a frictional force. Friction, we utilize this curly F. Friction is usually between the object and the material that the object is sliding along if we're dealing with one type of friction, or rolling along if we're dealing with another type of friction. But the idea is that the object and the surface that the object is on. Now, the direction of the frictional force is important. The direction of the frictional force is always opposite the motion. So that's our idea of frictional force. Now this categorization is going to be pretty simple and straightforward. We will get into frictional forces in more detail and really defining what is a part of a frictional force when we analyze friction, when we look at friction in detail. But that's another one I want you to be attentive to. Another force that we often talk about is what we call the normal force. Now, the normal force is just the result of two things being in contact with one another. When two things are in contact, like this book on the table, the molecules of those two things squish together. And molecules have a little bit of flexibility. They want to push out. So if I'm squishing on something and I want to push back, I'm exerting a force. So the book is pushing down on the table. And the table is pushing back up on the book. So the normal force is really the force the table, in this example, the table exerts on the book. There's still always two objects. The normal force, which we sometimes designate with a capital N, which can get confusing because that's also our designation for Newton, okay? So you have to keep your variables straight. The normal force is between the object and also the surface the object is touching or resting on or pushing against, leaning on. So it too is between the object and the surface. It's a different type of force than the object and the surface in terms of friction, but it is the same surface. So the normal force is something we're going to talk about and use when we talk about frictional forces. And we'll go into that a little bit more in its own mini lecture. Another force that we want to talk about or be attentive to is what we're going to call a tension. In general, a tension is going to be between an object and one of a number of different things that are essentially massless. It might be a rope or a cable or a chain, something that is in between the object and maybe something that somebody is pulling. So a physical entity like a rope that's going to be taut, tight under some tension, and that tension is causing a force on the object. So if I were pulling on this book with a rope in that direction, then that rope would have a tension. We would call that the tension force, and it would be between the object and that rope. Okay? Now, there is also a kind of a tension force, similar. It's something that's pulling, but it's if it is a spring. And the reason I am identifying this differently than the tension force is because spring forces have a very specific direction property. It will be between the object and the spring itself. And we're going to talk about the spring force when we talk about Hooke's law. We're going to have a little mini lecture on Hooke's law. But the idea is that depending on whether that spring is stretched and therefore trying to contract back and pulling the object in the direction opposite the stretch, or that spring is compressed and trying to push outward and therefore exerting a force on the object opposite the compression. And so a spring force, we pay attention to the direction when we pay attention to how we have influenced the spring when it's just at rest. Have we stretched it, and therefore the force will be opposite that stretch? Or have we compressed it, and therefore the force will be opposite that compression. So these are some of the forces we're going to deal with when we have objects and trying to analyze the motion of those objects. When they're just moving on a surface, when friction is involved, when things are being pulled, when springs are involved. These are some of the ideas I want to introduce you to in a very categorical way, so that when we get into them in detail, we are understanding that they're all part of this big picture. All right, good job.